And that it was on my like 4th day of working that I realized that to just get people to leave, all I needed to do at my job at McDonald's just put the fries in the bag. Whoever's reference that was. All right. That one feels like it's just getting drowned out there. So we're gonna try to come back to it. Cool. I'm trying to relate pressure in what units? P is the variable that I'll use. The units are kilograms or mass per volume is how you talk about pressure, but that's not our class, so we'll not specify that. Does it look like it's grayer here? Or weird, I wonder why. All right, anyway, we are trying to relate these guys together. What varies? V, I think, or I just heard somebody from the hallway. Volume is exactly dictated by what? K. I thought I heard it, but it sounded like it might come from outside. What's K? The constant of variation that we're dealing with. Cool. Times, so let's see, directly is temperature, KT, over P. Everybody cool with that? Now, that's where we stopped yesterday, I believe. To make this model actually useful, we need a value for K because it depends on the gas and all the different things that we're looking at. So on B, we're asked to actually find the pressure when this stuff is given. Now, in solving this, and again, I'm sorry about the format on your page. You're going to have to just do it all under part A, mostly. And I'll just do all mine under part A. What can we plug in that we know in this equation? And I'll scroll up. And all of a sudden it feels like physics, but I'm trying to not set up exactly like a physics problem. Anything that you know? Do you know the volume? When it's 10,000, and it will play the unit game here in a minute. I still don't know K because that's what I'm trying to solve for. And the temperature? 360 Kelvin. And let's see the pressure. 1.9. Now, we have this lovely thing that in a physics class we focus really hardcore on the units. If I said plug it in and solve, or just solve with the given information, this is probably the route most of you would take, right? You just plug it in and then you solve it. Can you guys solve this? Okay. While you're doing that in a different color, you might need a calculator, probably need a calculator. Solve this for K for me.
No.
Yes? I don't think you were talking to me. And then in a different color, I'm just going to highlight here what I would do. There we go. I am happy to show the middle steps, but just in case, to solve the one in yellow, I multiply by 1.9, it gives me 19,000. I then divide by 360, and everybody knows 19,000 divided by 360, 52.7 repeating. Obviously, I didn't know it, right? Okay. In green is what I normally do, though. Because numbers can be really ugly, especially if you get real data, I would hold off until the very end to plug it in. Now, there's a natural question that you're probably going to link more with physics than here. What's the unit on K? Anybody know? That's a hard question, right? Now, I'll tell you, it's a constant of variation. There's no units on it. There shouldn't be. When you're doing this, unit game in here, just save it for physics. Do you care about how we get the units to fall out, JV? Do you care about seeing why there's no units, or are you okay with just saying there aren't any? Okay. It's going to bug me. I'm going to come back and do it later just to show you guys. We don't have to write it down. Now that we have K, can we make a good model to predict stuff? And by that, let me rephrase. Now that we have K, we're going to make a model that we can use to predict stuff. So check it out. If we're trying to find the pressure when this stuff all exists, we now have a good solid model. We know that the volume, based on this type of gas, whatever it is that we're taking our data from, is going to be found by taking 52.8 times the temperature, T, in Kelvin, divided by the pressure, P. All that we've done in this problem is find that K are constant so that we can work it out. Yes, sir?
What does K represent?
K is just a constant, and it happens with a lot of stuff. So we'll see it in literally every one of these models that we're looking at. We had Kx or K over X. It's just some number that based on whatever information we start with, it's going to come out to be this every time. Like, it's going to show up in every single one of these. just a constant for now. All right, so we're trying to find the volume when what is true. Here's our model. That's our good model. And let's predict now. We're trying to find what? The pressure. Decision time. Do you want to rearrange and then plug in, or plug in and then rearrange? Do you know what I'm asking and understand the difference? I can plug it in one of two ways, and I'm just going to say whichever one you want to go with, I'm fine. What do I know the volume is? 8,000, so that would go here, right? 8,000 equals 52.8. What's the temperature? 400. And that's all divided by P. We can solve this for P now, right? Like you can plug in and then solve. Alternatively though, in white is what I normally do, and they're both equally correct. It's just a preference thing. I like to solve it and then plug in. Can I solve this for P? I know that if I just rearrange, pressure is exactly equal to 52.8 times the temperature divided by the volume. And I can just plug in and solve here. Whether you're going with the green or the white version, I don't care. Solve this for me. 52.8. We are solving it for pressure, yes. I hear 2.65 is one suggestion. 2.635, I'm going to just write it here. 2.635. $2.64. So I have a second. Can I get a third? 2.64 roughly. Okay, I'm fine with that. These are rounded. Now, here's the part that's wonky. You can cheat through it, quote unquote, like not actually cheating. You can cheat through and reason out what our units should be. If it's 2.64, whether you do green or white, the same calculation is going to happen. What's the unit on it? We solve for pressure, right? Okay. The pressure will be, and I forgot the number, it's 2.64 kilogram per centimeter cubed. How did Sean know it was kilogram per centimeter cubed? On the very second line of this question, the pressure of a gas is 1.9 watts. We can reason it out. Alternatively, we're not going to play the unit game because Kelvin's wonky. We're not going to mess with it. 2.64. Okay. This is part one, like the first problem we did. Love it, I'm good with this. It seems okay. Awful, let's do more together. Lots more together. We're going to do at least one more together, but I'm going to give you guys a head start on it. Before we move on, any questions about any part of this problem? I should always ask, what questions do you have about this problem instead of any questions, because the intonation is different in implication. Going once, twice, sold. All right, I want you guys to start number 2. I want you first, and it doesn't specify, on number 2, what I would like you to do with it, and we'll just try to stay consistent with this, I want you to immediately, before anything else, write out the model that you're going to use without any numbers. All I mean by that is it's going to be y equals something, or maybe not y in number 2, but write me the model that we'll wind up using, and then we'll find k from all of our information. Feel good, feel bad? All right, so let's check it out. I'll just try to stay consistent. We need a model first. Now, if you want it, we can write this down. These problems are all going to follow like the same basic template. Step 1, write your general model with k. You won't know it yet. Step 2, use the information they give you to find k. And then step 3, rewrite your model with a known value of k. Every single time we're running like that same thing. So let's see. I have energy E. And it varies how? It varies jointly, which in my mind I'm already thinking, okay, that's a product. K times something times something times something times something. Cool. So we get K. And it varies jointly as what? The mass m and the what? The square of the velocity. Man, I'm wrong. Why? Squared. Now, for those of you that have taken physical science, literally every single one of you, you dealt with kinetic and potential energies at some point in your life. You may not remember the formula for it, but we're going to see what it is. Okay, there's our model. M is a variable that we're going to have to know. If we know two of the three, E, M, or V, we can always solve these things every single time for the third. So let's just start trying to find K. What do we know about it? An object with something. I can plug in stuff. So I'm going to try to color code here as best I can, but if I get lost, please, or you get lost. M is 50, right? Okay, so I'm going to plug in 50 for my mass. Times my velocity is what? 16 meters per second. So I'll have times 16, and I'm not going to forget to do what with it? Square it. That's equal to K times those things. Do we know the energy? 6,400, and it's joules. But notice we're not in a physics class. I'm just plugging in. I'm not worrying about the units. I'm going to trust that it does it. Okay. And I should make that 6,400 match a little bit better, so we're going to use yellow for that. Kinetic energy of 6,400 joules. At this point, anybody concerned or have issues with where I've picked any of these values from? All right. So what's 16 squared? 256. I'm just going to go a little step at a time. Is it okay if you want to take bigger steps through than I am? Doesn't bother me one bit. You're absolutely welcome to. Let's see here. 50, and this becomes, you said 256? All right. What would you guys do algebraically next? You would multiply them? Okay. So let's see, 256 times 50, I have no idea. All right, and I'm just going to use one color here because I'm not going to mix them. We'll stick with green. Say that number again, 12,000 what?
800.
And to solve for K, finally, last step, I will divide both sides by 12,800, and to me that looks like it's going to be 1/2. Occur. We have a model. Check. This model's perfect, except we didn't know what K was. But we do now. Hey, here it is. That's 1/2. So K, check. Now to use this model, all we have to do is rewrite this with the known value of K. So here we go. We can now use the following model to make predictions. Pretty natural, I think, to call this 1/2 mv squared. I prefer mv squared over 2, but you do you. There's our model. Have we really answered the question yet, though? No, but the good news is that all of this is required to answer the question. We've done the hardest part of the problem. I want to know the energy when something specific is known about it. So we're trying to find the energy with what? So it's going to be in joules, but you're trying to find the energy of an object with some known stuff. And we're just going to do it this way. What am I going to plug in for what? Now, plug in and I get some values because we got to make a prediction. So mass equals 70. And velocity equals what? 20. This part in orange, it is entirely up to you if you wanted to write this part. Like always, it's up to you what you actually want to write down, just so you're all aware. I'm going to try to do better about showing more work. So let's see, the energy when we plug these in, it's still equal to 1/2 times 70 times 400. Okay, quick, because I hear calculators clicking. You don't have to. When you guys do this multiplication without a calculator, how do you do it mentally? Can you do this mentally? So you might do 7 times 4, that's fine. And then just add the zeros. Here's what I do. I can move multiplication, right? Like this product is the same as this one, is the same as this one, same as, I can't do it. What's half of 400? And I don't want you to think of distributing, I'm just rearranging. So in my head, I'm already thinking it's 200 times 70. 2 times 7 is 14, and how many zeros are needed? 3 of them. We get a solid 14,000 joules, capital J. Now, I have made a very conscious decision to start with these problems where they're like, it feels like a physics class. It doesn't feel like our physics class yet, but our physics class will feel like this at some point. We're going to see it in every physics topic that you ever deal with. You're going to see it varies directly or inversely. Like that language is super common in the world of physics. I want us to do one more together, and then I'm going to give you guys a little bit of time to work on it amongst yourselves. But I don't want to just do a straight up applied problem. I want to do this one together. I want to do number 4 together. And then you guys will just be tasked with doing the rest of it. I'm going to copy this one down. And let's take a look-see. What is the most important thing? And I'm going to pick somebody random. The most important thing that hits your eyes immediately when you read problem 4. And I'll be number 13 just in case it happens. But number... Charles! What's the most important thing that you read in that sentence, in your opinion? Oh my, directly proportional. Right off the bat, I have a model. Y is directly proportional to X. How on earth would you write that model? Number... Kalisha. Y is directly proportional to X as a language. All right, so check it out. What's wrong with this model? Like, it's good. I like this general model. What do we need? Louder, JV, sorry. So it could be the nth power, but it's just proportional to X. If I don't specify, what do you think the power is? Could we write to the 1 if we wanted? Do you need to? I'm not going to. You could. That is the nth power. It just happens to be 1 unless otherwise stated. Man, this model works fine and dandy, but I need something to be able to write this clearly. We're going to be able to plug in Y's and X's to predict stuff eventually. What do I need, though, to actually write this model? Because it's not complete. I need K. Man, so step 1, here's our model. Step 2 is find K. Let's get it. Oh, man, if only I knew some stuff. What's 1? Y is 1, and I won't use yellow because that's the color I just used. Y is 1 when what? X is 2. Well, check it out. There's a Y and an X right here. Let's just plug these in. Y is equal to 1 when X is equal to 2. I typically do not take 2 steps here. In my mind, I hate this. I just call it 2K when I write it. I rearrange stuff. I will do that eventually. Can you solve for K? Divide each side of the equation by what? Divide by 2. I need a shortcut button to change colors. What's K? We now have a model, an incomplete model, and we just completed it because we know what K is. What's our actual model then? Y, oh, louder, whoever said it. Y equals 1/2 X, and we're done. Now, the only part that extends on this, and this is something that I think shows up in your Algebra 2 books. If I have an Algebra 2 book in here, I'll show you. You guys, I think, did this stuff last year, at least a little bit. The problems as they show up in math textbooks, typically, if it's not a really like applied approach, is find X when Y is 7 if X equals 2 when Y equals 1. And so like they'll give you this all this information they got to parse and like separate. I don't give you any of those ugly ones. All right. I want you guys, give me like 15 solid minutes. I think you'll be able to finish this. And then we'll talk about what we're going to do moving forward. Bet. All right. I'm going to find you guys word of the fact, word of the day, history fact, or fun fact while you're working. All right.